All right. One second, and we'll get started. Let's check on this. Cool. So, just a quick reminder. I've said this if I said this at I think the beginning of the last couple of streams. And I think I'm probably going to keep saying this. Um, just a reminder that the purpose of study halls is to give you all a venue to ask questions on stream, and these will be things that I'll mostly just go over. So be specific with your questions so that I can answer them in a way that will be useful to you, and potentially this will be useful to others as well. And I want to use this as an opportunity to kind of showcase workflow aspects, and like talk about how I approach going over problems. So I might kind of repeat those things just to reinforce them, and especially for like people who are new to stream. But also, I think the workflow elements of programming are important, and they're easy to overlook. So I want to give those some airtime as well. So, um, great. So if you do have a question, um, it can be a question from Learn, or it can be a question from like Code Wars, or it doesn't have to be only from Learn. Obviously, I kind of have the best ability to help you with a question from Learn. It does have to be within the scope of what Learn would cover, though. So if you've got some really, esoteric question from the some corner of the internet, I may not be able to take it on stream. Um, if you have a question, send the link to wherever that is so I can go read the problem statement. I've had people just send me code, and they, just kind of ask like, "Hey, I tried this out and it's not working." Um, a lot of times that I just can't do a lot with that because I need to know what it's intended to do in order to get it to understand how to get it to do that. Um, so do send me the link. If it's a question in Learn, let me know if it's like which challenge it is so I can find it so I don't end up answering the wrong question. And yeah, okay. Sorry, the link and any code that you want help with. If you don't send me any code, I'll just assume that you want me to solve it and talk about how I would approach solving it. And if you have a specific like request about like, I'm trying to do it in this specific way, let me know so I can get an idea where you're thinking about. But at least give me the link, and if you have code that you want me to share, then share that. Cool. Otherwise, if I don't see any questions, I'm going to be going through the material in Galvanize Learn. And yeah, we'll go from there. So this time we'll be going through manipulating lists. And let me just check. Oh, awesome. Cool, we do have a question. Let's take a look at this. Real quick, let me just pull this up on my phone here. Oops. Okay, there we go. So can we look at tuples, creating tuples, challenge 3, given a hint that the tuples may not all have 3 elements each, as I get an error message of index out of range for index 2, but I still can't solve it. Cool. And the question asker did provide code. Awesome. Let me just copy this code real quick. It is really hard to view it all in Slack, excuse me. I feel like Slack used to be better at this, letting you copy code. Maybe I'm wrong. We're probably always terrible. Okay, cool. So let me just make sure. We do have. Cool. Good. All right, so let's look at tuples number 3. So first thing I'm going to do, and yeah, first thing I'm going to do, I'm just going to read the problem statement, get an idea of what this function, there's 3 things that I'm looking for. What are the inputs to the function? What are the outputs of the function? What's the output of the function? And what does it do? What process does it, what's the process that it needs to undergo? You know, things that I must do and must not do, maybe special cases, things like that. So input, process, output. If you're looking for kind of a checklist to go through a problem statement, you look for the inputs into the function, the process, and the output. So I'm going to be kind of reading this, thinking about that as I'm reading through this and kind of taking notes. When I say what I'm looking for, when I say I'm looking for like what it takes for the input and what it returns, specifically I mean what type, what data type does it take? You know, does it take a string or a list or an integer, and does it return a Boolean or an integer or float or whatever? So that's the kind of schema that I'm operating with as I'm reading through this. Okay. Oh, I'm just going to copy this straight in. Do that. So write a function called tuple creating tuple. Yep, that's what we got. This function takes 3 arguments called, and I just like to bullet these. It's personal preference. Name, age, and job type. What do we have? Name. I'm just going to check the spelling on these. Good. Name, age, and job type. Okay, so these are the names of my inputs. Given that they're called tup, I assume that they are tuples as inputs. The 3 tuples, that confirms it, are parallel since they contain the same number of items or elements. So since they contain the same number of elements, and each item at a given index corresponds to the other items at the same index. Okay. So this describes that the 3 tuples are parallel and justifies that by saying why they're parallel, and basically just describes what it means to have parallel data, where you have lists or tuples, and information corresponds to information in the other list at the same, or at the other collection at the same indices. Okay, so index 0 across all 3 holds the same name. This is just an example of the above. I'll just say e.g. Index 1 holds the name. Okay, so wait, what is this? Is this not an example? Index 0 across all 3 tuples holds the name, age, and job of the first person. I see. Okay. Index 1 holds the name, age, and job of the second person. Index 2, the third person, etc. Okay, got it. So I'm just going to do this. Bullet this again. Tab bullet. Okay. You don't have to format this stuff like I do. This is part of just kind of dyslexia survival stuff. This function should return a single tuple. So I'm just going to say this, return a tuple where all of the values at given indices are tuples of the data for the same person. Okay, it doesn't actually specify the order it wants that data in, but I'm just going to assume it's going to be the order of the arguments. So I'm going to structure the output name, age, and job. Cool. Okay. So I can already tell one, without even really reading this code right away yet, I noticed this tup 1, 2, 3, and 4 isn't giving me a clear idea of what data is being held in this. Maybe there's a reason for that. Sometimes it's fine to just number these. But nothing occurs to me off the top of my head, just seeing the way this data is named, which may be okay. But often you want to, you're going to want to, give things descriptive names. Cool. Okay, so tup 1 is name tup sub 0, age tup. Oh, I see what's happening. Okay, so the person who asked the question has a comment. Part of their comment when they asked the question is, let's see, that they were given a hint that the tuples may not all have 3 elements, which is what I'm noticing as well. Instead of working on this function like this, I'm going to write some tests so that we can have something concrete to test against and something to expect. So we'll tuple creating tuple, and then I'm going to say names equals a tuple of do that, and we'll do ages, and we'll do job. Let's see, so ages are going to be 57, and we'll say what job should I have? Should 57-year-old me have? How about and how about that? Okay. Cool. So we have some people, we have some ages, and we have some jobs. Good. So each of these tuples only has 2 elements. Part of this is because I'm lazy and I don't want to spend a whole long time making long tuples, but we could do that as well. So I'm going to pass my names, ages, and jobs tuples in that order. So we'll say names, ages, and I need to make jobs plural. Jobs, we'll make jobs plural. Obviously that's not syntactically significant. It's just a more meaningful name since these are collections of names, ages, and jobs to name them with plural words. Okay, cool. So in this case, each of these tuples has index 0 and 1, and we're doing something here where we're asking for index 2. So we're going to get an index out of range. Of course I have to, there we we go. Cool. Says index error, tuple index out of range. It's going to point here at line 23 because we're asking for name tup, and we're asking for the second index at these tuples. Cool. So I see the intent of this approach. Like, you know, the spirit of the question is here, but we need to, when you're writing a function, you're always thinking about how do I make this as generic as possible. And anytime, you know, sometimes you'll see me like I'll code something for a very specific scenario in a function just to kind of explore it, but then I'll go back and like rewrite it to make it very generic. So so we need something that is going to dynamically respond to the length of the tuples. Obviously, the amount of tuples is always going to be a constant. We're only going to have 3 tuples here. Sorry, the babysitting my my roommate's dog, my housemate's dog. She hurt her leg, so I have to keep her on my lap, and she's trying to run around. But anyways, cool. Hey, dog. Okay. So we want to build this in a generic way that's going to what did I say? Respond to the length of our tuples. So we're going to assume user responsibility. What that means is, you know, we could build this to be so generic, or, you know, generic enough that it could handle, we could reason about like what if the user passes in a list, or a tuple with a of uneven lengths, right? So if they're not all the same length, but we're just going to assume that whoever's going to use this function is going to do so responsibly and pass in tuples of all the same length. And there's a couple ways I'm thinking to do this. So I think the best way is going to be, oh, my the dog is resting her chin on the mouse. Oh, that's adorable. Can't do that though. Okay. The first way that I can think of to do this is I'm going to do this in a way that's kind of in the spirit of this solution. Oops. So I'm going to do an indexing approach here, but what I want to do is I want to run this through a for loop. Okay, the dog is resting her. Okay, maybe this is going to work. Okay. Sorry, folks. So for I in range len, we're going to get the length of name tup. Okay. And we could use any of the tuples here. Cool. So I can just accumulate into, let's just call this tup. We'll say plus equals. Obviously, we have to make it exist as a tuple. We'll do an empty tuple. This is the tuple accumulator pattern. Oops. Tup equals tuple. Can I just do that? Yeah, I can just do that. Tup plus equals that. And then we're just going to return tup. Yeah. So in order to do this, I have to subscript at I. And this should give me, right. So what I need to do is nest this. Each of these need to be nested. And this is a single tuple. Yes, there we go. That will work. Okay. So this is a bit of a funny one since we're doing a nested tuple. So I believe this solution is going to work. It's entirely possible that I became distracted by the dog and forgot what I was doing. That kind of thing happens. So we'll see. Cool. So this solution will work. So we can do for I in range, and then we need a limit for the range. We'll just use the length of one of the tuples, and we'll use the I to index into each tuple. Notice this comma at the end. I wanted to nest this inner tuple inside. So what I had to do is make the outer tuple, which is going to be concatenated into the tuple variable called tup, right? I needed to make this a single unit tuple. And the way you do that is just put a comma behind it. So it looks a little funny, but that's how you make it into a single tuple. Okay, so this is one way to do it. I just wanted to show it because it uses indexing. I'm not sure. I'm assuming that at this point in Learn, we've talked about enumerate and zip. Oof. So zip, I think, to me, is the obvious solution here. So let's do zip, and we'll do this. So for name, age, job in zip, name, tup, age, tup, job, tup. Cool. Now we'll do tup plus equals name, age, job. Cool, so I get that single tuple of everything like that. So now I want to nest again. We'll just, oops. We'll do that, nest it. Cool. So this should also work. Try that. Cool. So here's another, oops, oh, I just clicked somewhere. That's great. I like keep doing this. I don't know why it's like I can't use Google Chrome specifically for some reason. Let's run those tests again. Okay, cool. There you go. So this syntax might feel a little funny. This is a concatenation, just a accumulation. Pretty straightforward. If you wanted to think about this as a list accumulator, you could. Oops. Sorry, dog. Sorry, I need to readjust the dog in my lap. She's falling out. There you go. If you wanted to think about this as a list accumulator, you absolutely could. So let's just call, I need to do this. Let's just call this list just to, stay coherent on this. And we'll just do a standard append. Dot append. This is fine. Oops. So I want to append. In this case, I still need to nest parentheses, but the first set of parentheses is the parentheses for append, and the second set is a tuple. So in this case, I don't need a comma here, since this set of parentheses, this outer set, is for the delimiter for the append inputs. And the input that I want to append is just this tuple of name, age, and job. So if I run this, we're going to get really similar output. If I submit it, we're going to get an error. This is going to say self-assert, da 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 da. Okay, well, this is a little hard to read in this format. Let me actually paste in this error here, and we'll do this. Okay. So this is doing, let's see if I can get the, I see, okay. Okay, so this is the expectation. Give me 1 second, folks. Somebody's knocking on my door. All right. Cool. Sorry about that. My roommate just came back with pizza and came back to grab her dog. So, good. Thank you for your patience. So what I'm trying to do here is just format this first call and show the input and the output. So let me do this. Let's do this. Okay. So we'll do this on one line. Name, comma, age, comma, jobs. These have to be names, ages, jobs, oops, equals these tuples, and we'll just come back past these into our call here. And then this is what we expect for the output of that. Okay. Cool. Sorry. I didn't even need to do these 2 lines. So this is the part of the error that I was trying to isolate. So notice it's saying this first thing is not equal to this second thing. And if you look, they appear to be pretty similar, but one is surrounded by square brackets, which means it's a list. The other is surrounded by parentheses, which means it's a tuple. So I can just cast this list as a tuple and watch it change from a list to invalid syntax. There we go. Watch it change from working to broken. Okay, list to a tuple. Good. Let's see if that works. I mean, it's the same thing. It's just I'm converting it to a tuple. So this is another way to solve this problem. Good. And to the original question asker, this is the first question that was asked. Let me know if this is helping or if you have any follow-up questions. I figured I just wanted to give a few multiple perspectives, different ways of thinking about this. I wanted to solve it with a list as well to show you lists and tuples are similar. If you need one but you're more comfortable with the other, you can, this last line here should give you the idea that you can very trivially easily cast a list as a tuple and a tuple as a list if you need them to be one or the other. There are advantages to working with lists as lists and working with tuples as tuples. They have their own pros and cons for why to choose them and why to work with them directly. But for now, if you're just trying to get some coding done and you're more comfortable with one than the other, then you can absolutely just cast from one to the other. So this makes sense now. Bottom line is using an accumulator we have multiple options to dynamically solve it. Indeed, yes. This is why we put such a big emphasis on accumulators, because, I mean, I don't, partly because when you're dealing with collections of information, you don't know the size of that information usually. So you can make something that's going to adapt to a size by doing 4 item in collection of some size that you don't know, right? And this is why this, I I'd be hesitant to say this is the only reason, but I mean this is definitely a large reason. You're writing functions that are meant to handle data of varying sizes, and a for loop is just, I mean, it's designed for that purpose. So, if you're wondering, this is a good, I guess, a good rule of thumb. Like, if you're approaching a new problem, you can probably just assume that it's an accumulator pattern until you prove to yourself that it's not. Uh, it's such a powerful construct. There's a lot of problems that even that you can solve without it, but if you can also solve with an accumulator pattern anyways. So that's kind of an interesting thing. Sometimes you don't need it, but you can use it anyways. And in terms of just getting things done with code, like, that's fine. Like, in certain cases you may be some advantage or reason to do something in a different way other than an accumulator, but if you can use an accumulator, it's going to produce working code, so it's not that big of a deal. Good. All right, so here's our working code. Nice. Okay, cool. So I agree. I've done that in homework section a few times. Used the dir function. Nice, nicely done. Yeah, cool. The dir function is a very, very useful function. Very useful indeed. Cool. All right. We have another question here. I really want to, like, I'm resisting the urge to, like, solve that one with a comprehension. So I think it'd be fun, but somebody else has a question, so right thing to do is to just move on. Cool. So this question comes from someone else. I'm a bit confused where to start with the third challenge in replace section of string functions. Oops. Do you mind going over it? No, I do not mind. It would be my pleasure. I'll leave that up. Maybe I'll come back to it if we have time. Maybe we can do it as a comprehension. Thanks to y'all who are putting in questions. This is what, I mean, I know I literally just said this, but this is what it's all about, and it makes it fun to do, and I think useful. Awesome. So here's replace. By the end of this, you'll be use replace. Okay, let's see. Get confused where to start with the third challenge in replace. Okay, we're doing the third challenge. Okay. All right, so remember, I'm reading the problem statement. What am I looking for? Just give you a second to think about it. Recall what I was talking about beforehand. So as I read this, I'm looking for the inputs to this function, the process, and the output. I'm thinking about those things and gleaning that specific information, or those categories of information out of this text. and at least in all of our materials, we try to write them in a way that they include that, um, which is how you write specifications for functions in the real world. You write what are its inputs, what does it do, and what are its outputs. So you don't always have that luxury, because sometimes you're looking at you're looking at data in the wild or a problem out in the wild, and you have to think about what those things are. But as you think about it, if a problem statement like this isn't provided to you, which often it will be, often the senior developer or the senior engineer on a team is going to write function specifications that the junior developers will implement. So that's a fairly realistic workflow. But if you're the one out there inventing the solution, and analyzing the problem out in the wild, which you will certainly do that in the DSI and in your careers at various times as well. You're looking for this information nonetheless. You're thinking, I'm writing a function. What are its inputs? What's its process, and what's its outputs? I even write little doc strings like this, just very succinct, usually very short, as I code, just to kind of remind myself, keep myself focused and on the rails. Gives me a nice little checklist, and pretty straightforward. Usually pretty straightforward, which is nice. Okay, cool. So write a function called replace doubles. Let's write some tests. And replace doubles. I don't know what its inputs are yet. I'm just gonna do this, and we'll return. There's our little boilerplate. It doesn't have any meaningful return or input yet, but we'll get to that. This function takes, here's my input, a sentence as an argument. So let's just call this text. I'm just going to call it txt. Takes a sentence as an argument, then checks for any double letters, for example, AA or TT, and replaces the double letters with just a single instance of that letter. Very interesting. All right. Okay, so this function takes a sentence as an argument. So that tells me my input. It's a sentence, presumably. The only data type that I can think of that's really going to represent a sentence correctly is a string, right? So we could do, you might say, well, a list of strings, but we're just going to assume it's a string. Okay, so then it checks for any double letters. This is describing the process. For example, AA or TT, and replaces the double letters with a single instance of that letter. Presumably returns it. Excuse me, I'm having a thing going on. It replaces and returns a string with those examples replaced. Cool. So this is talking about, this is the replace method. Am I wrong about this? Okay. 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 I see. Cool. So let's do this. It's going to return, it's also going to return text without doubles. So let's just call this clean text. We'll just do that. Make this exist. Empty string seems good. Here's an accumulate. We're starting an empty string, like anytime you have the thought, well, I need to start an empty thing, like you're setting up, whether you think about it consciously or not, you're setting yourself up for an accumulator. So I see an empty variable. It is not useful currently on its own, so I better put stuff in it in the way that I know how to do that is with an accumulator. So we'll say for, let's do character. I'll call it ch in text. And we'll print ch. Oops. That. I'm going to grab some input text here. I don't know if there's, oh yeah, there is. Here's some double letters. Here's some double letters. You know what? I think, yeah, I'll just shorten this so we don't have a lot of text. It's often good to test on just a little bit of data. Makes it cleaner. Or it makes it, well, it makes it easier to, I don't know why I said cleaner. It's probably because I read the word clean. It makes it easier to reason about quickly by eye, you know. So we'll just pare this down. So let's see here. I can even, it wouldn't be that hard to just scrub this really quick and just go through this and look for double letters. So WADs, yes, I might even miss a couple. Feel free to put it in the comments if I miss a couple, though I'm probably going to ignore it for now. But just give me some idea of what I should see. It doesn't need to be perfect. See. Hey, there you go. Stopping. Here to see. Watches, woods, fell. Cool. So this is the input text that I'm going to use. And this is just a note to myself to, you know, have something to reference. You don't really need it in this case, but yeah, why not? It was quick. Okay, so we're gonna call our function, pass it text, and return clean text. Currently, if I run my code, I should be printing out each character in the input text. So now that we have some test data, we've done some reasoning about our expectation for what this function should produce. Given that test data, we are printing out the return of our function, which is not meaningful at this point. It's going to be an empty string. But we've got our for loop. We've kind of got a basic structure laid out. So let's just give it a run and take a look. Cool. So this looks correct. That looks like each character in the input in this input text. So that's great. Every time I suggest this, every time you write a for loop head, just print out the identifier that you create in the after the for keyword. If there are multiple identifiers like in the previous problem, just print them all out. And that gives you a sense of what you're looping through and what the loop is giving you back. It's just a good place to like check in, make sure you don't have any other syntax errors, make sure that you've seen the data, you've put your eyes on it, you have an opportunity to like just register it on a different level. And if you get in that habit, it literally takes no time at all to just do that check really quick. So good habit. Cool. So I'm thinking I need to compare the character to a character like next to it. So there's a couple ways I could do this. I think sort of the boneheaded way is to just have a variable previous ch. I'm actually going to do this up here, and we're just going to start this as an empty string. And then I think what I want to do is the first trip through the string, I want to say previous ch equals ch, and then just move on to the next, like just not execute any other code, just like skip that iteration entirely and just move on. So what I could do is I could say if, now I need something to check, I need to be able to check if this is the first iteration through the loop. So I need to be able to check this condition. You can think about how you could do this. There might be multiple ways. My preference is to enumerate. Now I have an index, and that's going to be unique to every trip through the loop. So I'll do idx, comma ch, and I'll say if idx equals 0, then I know that that's my first trip through the loop. So enumerate can kind of give you sort of a map of where you're at in the loop if you need that. This can be really useful. Like basically every time I have a problem where I'm comparing something in the list to like something next to it, either before or after, something like that, I'm using enumerate and I'm doing this trick. This is the first check if first iteration. We'll just do this. Oops, there we go. So if idx equals 0, what I want to do is say previous ch equals ch. And then what I'm going to do is just continue. And that's going to skip any other code in here, right? It's going to execute up until this continue, and it's going to go to the next iteration of the loop. It's what continue means is, hey, I'm done with this trip through the loop, so don't look below this continue. Just stop and move forward. Cool. Okay, so now what I want to do. I am going to need to run this code again at some point at the bottom. This will need to be the last thing that I do. I think probably the last thing that I do, or close to the last thing that I do through each trip of the loop. That way I capture the current character as the previous character and then go into the next iteration of the loop with previous character being the previous character. Cool. Hopefully that's clear. I'm not sure how clear my explanation of it was, but hopefully that's clear. Also, if it's not, just let me know it's not clear and I will attempt to re-explain it. All right. Let's just run this and see what happens. Nothing's going to happen. Nothing at all is going to happen. I'm not printing anything. Good. Okay, whatever. So I think what I want to say is we're looking for doubled characters. So I think what I want to say is if ch equals previous ch, now we can use the replace method. Let's do text equals text, clean text, excuse me, clean text equals text dot replace what do I want to do? ch plus ch with ch. Okay. So this says if the current character is equal to the previous character, then replace, and let's do this. Doubled ch equals ch plus previous ch plus previous character. So doubled character equals current character. Maybe I should call this current character to make it clear. Current character. Okay, so doubled character equals current character plus previous character. Makes sense? So at this point we can replace the doubled character with the current character. Good. Okay. So I see a problem up here. If my input text has no doubles in it, my clean text is gonna be nothing. So hopefully that's clear why. So let's just run this and test it at this point. So whose woods are the da-da-da? Okay. Oh. excuse me, clean text. There we go. Yeah, okay, so I do need to do that. I need to do this actually right away. I'm just going to do a copy of text. We'll do clean text equals text. And this just occurred to me. Since strings are immutable, there is no reason to not just use text like this. And then I'm going to actually just reappropriate my input as my accumulator. Often that's a bad idea. In this case, it's going to be okay. Okay, so whose wads? These are, I think I know, his houses in the village with 1L. Cool, okay, good. I had to fix that other problem. Let's just see if this is going to work. Fully expecting this to fail. We'll see. Okay, it ran. It worked. Let's see what their solution is. It's way simpler than mine. Of course it is. Oh, okay. That's great. So easy. So nice and easy. Let me just copy this. We'll talk about their solution here real quick. So, their solution, I'm actually just going to copy this really quick. Also, let me know, to the question asker, let me know again if this is helpful, if this is helping you understand and answer your question, or if you need more. What was this? String equals. Oh, okay, cool. We'll just do it this way. Do sort of a hybrid. And you know what? I'm actually just going to do this. And we'll do chars. We're going to say for char in, for character in characters, plus we're going to concatenate characters dot upper, and that'll give us uppercase characters as well, and it'll keep that just that line just will be shorter now. Then we're going to say I'll just, this is the line where the magic happens. Okay. Good. So we'll say text equals text dot replace ch times 2. That'll duplicate it. And this is going to go through and it's just going to, if there's a double of any of these, it's going to just replace it with a single ch. Cool. That's the same? Yeah, that's the same. Cool. That was a great solution. So this is a bit different. This is, I would definitely call this a kind of accumulator. It's a different kind where we're running through, instead of running through the input, we're running through the a different thing and checking if there's anything that's doubled, you know, from that pool, and replacing it if it's doubled, if it's there to be replaced. Oh, that's what I was going to do. I was going to submit this. Cool, that works too. Nicely done. And again, to the question asker, if that's making sense, let me know. If not, also just let me know, and that's fine too. I will do my best to make it clear. Cool. Wonder if I can rewrite these as comprehensions. Oh yeah, I definitely could. I think I could. That's interesting. How would I do... I just wanted to see if I can write these as one-liners. That'd be fun. Oh. Oh, no. I bet it's possible with this one. It's got some funky stuff going on. It's a little bit different. Might have better luck with this one. So the more... Huh. I could do a very sort of pure accumulation pattern. Be a little different than either of these solutions. And do that. I kind of want to come back to this first problem and do this one as a comprehension, and then move on to that second one that we just went over. Also, again, if anybody, I'm just doing this just to, give some different perspectives on this and just have fun and explore different ways of solving these problems. But if anybody has another question, or if anybody has a follow-up to the questions we just went over, let me know and I will take those. That'll be fine. Cool. So this is a traditional list accumulator. So for those of you who have seen me talk about comprehensions before, we can kind of do the sort of comprehension conversion that I like to do. We take our accumulator, crack it open, and then take our append, delete the actual part that says append, but then move the thing you're appending right into the front. So we're gonna get this and move. We're gonna move the loop head in like this, and then just kind of clean it up a little. Now this is a long comprehension. It's gonna wrap around onto the next line. When I get a long one like this, I like to just break it onto the next line anyways. Like maybe something like that. Cool. Let's just see if that works. And we'll see. I don't know if yeah. Well, that does work. Let's improve it again. Let's just return this directly. We don't need to set it as a list or anything. We can just return it directly. And we need to return a tuple, so we'll do tup, or tuple, excuse me. And we'll just put parentheses around these and get rid of that. And we've got a one-liner. I broke it onto multiple lines, but it is sort of in a more formal sense, it is a one-liner solution. All right, cool. So that's one way to do it. Yeah, cool. All right. Let's see if I could do this other more traditional, like pure accumulation sort of sense, or sort of solution. I don't know what I'm saying here. Whoa. Let's comment this out, and we'll clean this up a little bit. I don't know why I duplicated this whole thing. I didn't really need to do that. Put that second solution. Just gonna mark these. Solution 3, okay. So this will be a comprehension. So I think I'm going to kind of model it after this one. And I'll write the non-comprehension version of this first. So in this case, I am going to do a pretty traditional accumulator. We'll do clean stir or clean text equals empty string, and I think what I want to do here, I'm actually not going to use replace for this solution. I'm going to do clean text plus equals ch. And I think what I want to do is, I might totally be wrong about this. We'll do this in one. Get rid of that comment because it's kind of not relevant if I do this. Okay. So if idx equals 0 or current ch equals previous ch, then I want to assign previous ch to current ch and continue. Otherwise, it's sort of an else thing. I could do continue here, or I could do else. This code would work the same. Maybe this looks a little better for this solution. Else clean text plus equals ch plus equals character. Oops. Yeah, so I want to accumulate the character. I want to accumulate the character. Oops, and I want to call this current ch. There we go. Oh, okay. Cool. So you're saying the second solution makes more sense. The person who asked the question, this question initially, is saying that the second solution makes more sense. Honestly, it makes more sense to me too. It's a better solution. Not confident in the ability to use enumerate. Yeah, it does take a little, like, there's a little learning curve with enumerate, but it's also very powerful and yeah, very, very useful. Cool. Now I'm wondering about this. I need to find a way to like avoid duplicates. Avoid putting in duplicates. Well, I've got a little going on here. We'll see what this does. Okay, so this doesn't quite do it. Yeah, and this is going to put in my duplicates, since in both of these cases I'm adding in. I'm doing the concatenation. Let's just try this. Okay. Oh, of course. That makes sense. I have to actually return the right thing. Wow. Let's just see if this works. I'm not entirely sure this is going to work, but we'll just see if this solution works. And we'll go from there if it does. Feel like it's not right somehow. Yeah. Oh, yeah, okay. So in this case, I'm missing the first input letter, which is kind of funny. Because it looks like I'm getting it in this case. But let's try their input. TTERSS. Okay, good. So let's actually just try their input. LETTER capital SS. We'll try that as an input. Headers. Very interesting. So it's funny because in this case I missed this first letter. I see. I see. Now I feel like I'm starting to think that I don't know that I can. Yeah, turning this into a comprehension would be really funky. I think it's doable. I can think of how to do it. It's just very funky. I think I do need to break this out into its own condition. So I think these are there's slightly different logic. So we'll say elif. So if idx equals 0, then I want to do this with previous ch. Yeah, I'm starting to push a boulder up a hill here. I'm thinking about how to solve this with comprehension logic, and I'm doing it in a for loop first just to kind of hash it out. But it is starting to get weird. Yeah, I'm not sure that that's quite sure that that's the best use for study hall. I really want to, and I know it can be done, but should I? That's the question. Should I? Okay. I think that feels, yeah, it just feels a little out of the scope for today. Comprehensions are cool, but they can also be I was gonna say they can also be like too much sometimes. That's actually kind of a good reason. Maybe I should do this. I think I am gonna do this. I'm flip-flopping. So this, I'm almost certain I can do this as a comprehension, but it's gonna be a nasty one. It's gonna be a nasty comprehension. So let's just do it anyways. Instead of enumerate, and instead of this previous ch thing, I realize what I'm going to need to do is handle that kind of logic here. So I'm going to actually do zip, and I still need my index. So I'm going to do range. And we're going to do a range of the length of text. Oof. Okay. Then we're going to do text. Then we're going to do text. Oops. We're going to do a slice of text. And I actually want to yeah. Yeah. Okay, we're gonna do this where we start at index 1, so we skip the first one. And this is gonna be the logic we need for previous CH, which we're not gonna be using. Okay, so let's call this IDX, current CH, we'll call it current. Let's call it CRNT, CH, and PREV, CH. Maybe I should just call this current and previous. Okay. Cool. So let's change this into a list accumulation. We'll do a list, and we'll make these into appends. Do this, and we'll do, I think we need to do this for, if it's equal to previous, we want to do this. We just want to skip it. If IDX equals 0, we're not going to handle this here. We'll just skip that. So I don't want to override that. So I want to instead, I want to append something that's going to be a handle that I'm going to join on. So this is, I just call this join handle. We'll append that, and that will be the handle that we join on. Whew. All right, expecting errors. We'll see what happens. elif, that's going to be an if. Current equals previous. Wow, okay. So let's join string dot join. What am I doing? Dot join on this. Dot split. Oh my gosh. We're gonna split out. Oops. Nope. We can just do dot remove this. So much effort to turn this into a comprehension. Okay. Dot remove. Join handle. Excuse me. Replace. We'll just call this handle. Yeah, let's see what that gives us. LETER. I can't believe that worked. Oh my gosh. what a solution. All right. Cool. So let's see if I can manage this. So this bit has to go up front, and this will turn into a ternary. So we'll do actually, wow. Get rid of the append. Do that first. So we'll do this if current equals previous, else we'll do current. Okay. And then we'll take this in here, get rid of that. I did not need the index. Well, that's nice. That saves me a lot. I didn't use it. Cool. For current and previous in zip, text, and text from 1. Okay, so let's see if that works. I'm expecting letter, L-E-T-E-R. Okay, that's what I get. All right, and let's just do a little check here, make sure I didn't fly totally off the rails. Still got a little bit of work to do. To be clear, like I said, I hope this was implied earlier. Comprehensions are cool. I think I'm doing the wrong one. Nope, I'm doing the right one. It doesn't work. Comprehensions are cool, but you can see it's taking a lot of effort, and this problem does not lend itself particularly well to being a comprehension. Right. So I was actually getting the wrong result before. So what I actually want to do is dot append. We'll just append right onto this list. Text sub -1, which is going to be the final item, and we're actually omitting that, so can only join to an iterable. Oh, interesting. Huh. Why does that make it go? Oh, right. Dot append will do that. Oh, I'm being silly. I can concatenate. What am I doing? I don't need to do this append. I can say plus. Do a list there. Try that. Okay. That should work. Not sure. We'll see. Not sold on it. Okay, that works. Now all we have to do is wrap up all this onto this line. So, clean text here. We'll just put this, break this out like this, and da-da-da. Join that, and replace. Oh, look how wonderfully readable that is. I'm just kidding. That's just like a pile of, that's like a just, oh my gosh. Look at this. It's like soup. I can't believe that works. Okay. So okay, the reason I'm showing you this, to be very clear, if I haven't made it clear already, comprehensions are cool. Sometimes they make code simple and elegant. This is not one of those times. The reason I wanted to show this anyways, even though I knew this was going to be a beast, is to show you, like, you don't have to be doing, and I've encountered this with people. You don't have to be doing comprehensions to be a good programmer. Like, you don't have to be doing comprehensions all the time, or comprehensions exclusively, or even comprehensions all the times when you can, when you can use them or whatever. Here's a problem that could be solved with a comprehension. Should it be solved with a comprehension? I don't know. This is tough. This is kind of some brutal code here. So, yeah. So, yeah, just a quick note on that. Cool. So we do have another question in here. Whew. Okay. Let's see what this other question is. So the third question in list functions section, we've got a link. Oops. Isolate that link. So I think my current solution is close, but it's returning a single string instead of a list. Oh, it's single string inside of single string inside of a list instead of an actual list. Correct me if I'm wrong. Okay. So let's go to the link. And copy the code. So here is the code that was provided. Split remove. Okay. So remember, as I go through this problem statement, I'm going to be looking for input, process, and output. Okay, write a function called split and remove. Function should take a single, presumably a single parameter. Oh wait, let me. So the function should take a parameter called the stir, which contains a string. The function should return a list of the given string with all the vowels removed. Be careful not to change the case of the string. Also, for the purpose of this function, y is not considered a vowel. So I'm just do this. Note. For the purpose of this function, y is not considered a vowel. Good. So don't change the case. Okay. So presumably, let's just see what learn is saying about this code. So I'll just submit this code as it was given to me, and we'll see what the learn error has to say. Okay, cool. So we're reading the error from the bottom up. This bit you can kind of ignore. This is saying basically do without this, minus this, plus this. The plus is what it's looking for. In this case, we have a list of list of a string. I think we can just do. So instead of split, so this is kind of a funny thing, but split turns a string into a list based on a character to split on. Oops, the list function also turns a string into a list. And it just puts, every character in its own element in the list. places every character as its own element in the list. So it just makes a list out of the characters. Okay, so this actually just works. Cool, so let's just look at this logic real quick. We copy the string. We note all the vowels, what those are. For vowel and vowels, copy string equals copy string dot replace vowel with nothing, and then return list of copy string. So that's all that was necessary in this case. So this is a pretty, you were pretty close. You're very close. But take note of this to anybody watching this, because I definitely remember this being kind of a learning moment for me when I realized, oh, there are, when I want to make a list out of all of the characters in the string, I use the list function. When I want to make a list out of all the words or the sentences of the string, or I want to split the string based on a certain character, I use the split function, and that will also give me a list. So yeah. And this lesson is regarding the list function. So that's what this whole thing is going to cover. List function, etc. Cool. Nice. I'm wondering if I should try to rewrite this as a comprehension. Yeah, I'm going to do it. Okay. I'm just going to start over here. Let's see if I can just do this one off. Return list, and we'll just do ch if ch. Oh, I know. We'll do ch for ch in, oops, in the stir, if ch not in, we'll do ch dot lower, not in a, e, I, o, u. Cool. Let's just try that. Another form of a comprehension. We'll just see if that's going to work. Cool. So this is an example of a problem that lends itself well to being converted to a comprehension. In this case, we're asking for a condition at the end, which is something that you can do if you have a single condition that you're checking in a comprehension. You do that at the end. If you have an if and an else, you do that at the very beginning before the for part, FOR part. So in this case, we have this condition at the end, since it's only a single condition. And if this is false, it's just not going to do the thing at the beginning of the list. It's just not going to do that at all. It's going to ignore it, going to skip it, and move on. So, cool. Also, to the question asker, do let me know if that helped. Well, actually, yeah, DM me, let me know if that helped. I think this is a good place to wrap up. This is about our usual stopping time. I hope people found today's study hall informative and enjoyed it as much as I do. It's funny. I'm always like a little bit like, I get a little like, oh, I got to stream, and I get a little tense, and then as soon as I start streaming, I'm like happy and excited, and like I have a good time. So yeah, I enjoy these. I hope that comes through. I hope y'all enjoy them as well, and also find them informative and useful. Do let me know if there's anything that I can improve Especially if there are audio or connection issues. I know the resolution is low. I think it's like 360p is the highest right now, and I'm sorry about that. I'm aware of that as an issue, and I think it's partly to do with the machine that I currently have access to being kind of limited. I will be upgrading my computer uh, hopefully within the month, um, and that will allow me to uh, give higher fidelity streams. But yeah, definitely let me know if there's anything else, any other ideas you have, other topics that you'd like to cover. Won't promise that we'll do them all, but would love to hear y'all's ideas and input and feedback. Go ahead, feel free to like, comment, and subscribe if you feel so motivated. Let me know there, and DM me if you're on the Galvanize Slack, and I'm happy to interact with you there as well. Cool. I think that's everything. All right then. Well, yeah, it was a blast, and I will be seeing you on Friday. So Wednesday is normally a streaming day. Wednesday is a holiday, so I believe we're not going to have a stream. I may end up streaming, but I won't promise it at this point. So just expect that Wednesday will be skipped this week, and next study hall will be on Friday. If you're in Premium Prep, then I'll see you when I teach Premium Prep next. So y'all have a great rest of your evening.